Our main topic is gas chromatography today, and first of all, we'll discuss its introduction. Gas chromatography, or which is also known as gas liquid chromatography, is a very powerful and advanced tool which is used to separate and analyze the compounds which can be vaporized without decomposition. So they are vaporized without being degraded, even at high temperature. So in gas chromatography, mobile phase which is used is generally an inert gas like helium, argon, some other gas, while stationary phase is a high boiling point liquid which is adsorbed onto an inert solid, and this acts as a stationary phase. Instrument which is used in gas chromatography is known as a gas chromatograph. Instrument consists of a column which contains stationary phase and through which this sample is taken along with the mobile phase, ovens and heaters where the sample is heated, and then a detector which detects the sample as it passes through the detector. Inert gas serves to carry the molecules of the analyte through heated column, and gaseous compounds, they are made to interact with the wall of the column which is coated with stationary phase, and as this sample flows through the stationary phase, through the column, various components of a sample, they react with the stationary phase and they react with stationary phase with different affinities. Those molecules which react with strong affinities with the stationary phase, they elute later, while those which react slowly or which have less affinity with the stationary phase, they elute fastly through the column. This causes each component of a mixture to elute at different time, which is known as retention time, and this is specific for each component of a mixture. So A has its own retention time, B will have another retention time, and so on. So each component of a mixture has a separate retention time or specific retention time, due to which these are eluted from the column at their specific times. Materials that are less soluble in the liquid will be eluted faster than those with more solubility. We have discussed this point, that which are less soluble with the in the stationary phase, they will be eluted faster, while those which will have more solubility, they will be eluted later. Components of the sample move with the velocities that are influenced by the degree of interaction of each component of a mixture with the stationary phase. So this is how the sample is divided into its components. And components which elute from the column, they are quantified by a detector. Gas liquid chromatography or gas chromatography simply has many applications in pharmaceutical and analytical fields, and due to which this instrument is used in recent times in almost all types of biological, chemical, and pharmaceutical fields.